let's say that we are given two natural numbers A and B, and we are told that their HCF, that is HCF of A and B is, let's say, H, and their LCM is, let's say, L, right? Now, these are just some symbols or variables. We can, of course, take some numbers as examples. Like, let's say A is 12 and B is 30. We know that the HCF can be calculated to be 6 and the LCM can be calculated to be 60. Okay. Now, we know a property that connects the numbers and the HCF and the LCM, which is that if you multiply the two numbers, you get the product of the HCF times LCM. Of course, you can verify this for 12 into 30, which is 360. 6 into 60 is also 360. And the reason this is true is because the HCF is obtained by taking common factors when you prime factorize 12 and 30. And the remaining numbers will form part of the LCM. So when you take the product, they will match, right? Now, based on this idea, sometimes questions are asked. For example, suppose the product, which is AB, product is 200. Okay. Some people will ask you, which of the following can be the LCM? Okay. For example, let's take the number 75. Okay. So the question is, if the product of two numbers is 200, can 75 be the LCM? And when you are asked questions like this, you don't know what the two numbers are, right? So you are going to see if we can use this relation. So if you say 200 equals H into 75, then you will find that H is actually a fraction and it does not work. Many students understand this. But suppose the choice given is 50. Can the LCM be 50? And so what you will see is 200 is H times 50. And when you do this, you will get H is equal to 4, which is actually a natural number. So many people think the LCM is 50 and HCF is 4 can actually work. But there is a problem. This is wrong. Why is this wrong? Because this kind of doing only accounts for this formula, but there is an extra property that you have to be aware of HCF and LCM. And what is that property? And that is the fact that whatever you find as HCF is a factor of both A and B. Okay, HCF is a factor of both A and B, and A and B are factors of L. That means H must be a factor of L. So A and B are factors of L. Therefore, H must be a factor of L. And this is a very important idea. This means I cannot have two numbers whose HCF is 4 and LCM is 50. Why? You don't have to try and find. Whatever you do, you won't be able to find because 4 is not a factor of 50. Okay. Similarly, if somebody told you product is 200, can the LCM be 25? Again, when you do 25 into something, you'll get 200. You'll get 8. But 8 is not a factor of 25. So you cannot have this. So this combination is not possible. So this is a very important idea to remember, right? That there are many connections between numbers HCF and LCM. This is one connection. You should also remember this extra connection while doing problems.